Alright, let's solve the Leetcode problem. So, the Leetcode problem is a maximal twin sum of a linked list. In a linked list of a site n where the given linked list site is even and index of zero index of the linked list is known as a twin. So what I mean by twin is to the side minus 1, let's consider we have 1. And then 1 minus 1, that each index is, okay, let's consider size is 4. 4 minus 1 is 3. And 3 minus, let's consider index 0 is 3. Okay, so in that case, okay, this is just make us to confuse about what is the twins meaning. So if index is within the range of 0 and n by 2 minus 1. For instance, if n is 4 and then the node is at 0, the twin of node is 3. So node 1 is node 2. There are only nodes twin for n equal to 4. So the twin sum is defined as the sum of the node and its twins. We have to give a head of a linked list with even length and return the maximum twin sum of the linked list. Let's try run through the given experiment in here. If I'm not wrong, let's say we will always receive the size of the linked list in even number. Let's consider we split it into half and we do it like perpendicular to each other. So the twin of each linked list will be nearby 1. Let's consider the linked list of 4 of twin is 2. The same for the 5 is here. Okay, I think I can better explain in here. Let's say that we have a linked list like this. What I mean by twin is perpendicular is like this. So 5 is the twin of 1 and 4 is the twin of 2. So that I mean by perpendicular to each other. And the same for the experiment 2. So what they really want is we have to return the maximum of the twin. Let's see, 4 plus 2 is 6, 5 plus 1 is also 6, so we just return the 6. So that is the maximum twin sum of the linked list. How about experiment 2? So 2 plus 2 is 4, 4 plus 3 is 7, so we return the 7. In here, there's only 2 numbers, so we don't need to find the twin, like just return the total of combination of index 0 and 1. So I think we can use the two-pointer approach in here. What I mean by two-pointer is we have a slow pointer and fast pointer. Let's name this as a fast. Let's use the green for the first. And for the slow, we will use a blue color. Alright, so what I mean by slow and fast is slow will only go each one hop and the fast will go 2 hop. So let's consider that we want to find the half of our linked list. So our fast will go to 2 hop to here, slow will go here. So if this is become nil, so we will end up the slow in here. Alright, so by doing that, we can reverse the second half of the linked list and reverse it, and then we can find the combination of the twin and then return the maximum in here. By doing that, let's use a 2 variable for our pointer. Let's go slow is pointing at head and fast is also at the head initially, and then we want to find the middle at first. So to find the middle, fast is not equal to nil and slow also not equal to maybe we're still doing that, we can do something different. Fast of next is not equal to nil. And what we can do is we will do like slow will be slow of next, fast will be fast of next dot next. So let's get back to what my original intention is here. So we are checking with the first. So since first is doing with the do index champion, let's say we're here, so slow is here. So at the time we will check like our condition is first is not equal to nil. That's true because first have a value. First or next also have a value. So we'll let the condition to run one more time. So first we'll reach nil in here. So I'm gonna draw the nil because for the sake of visualization. And then we're gonna check like the conditions come to here. First is not equal to nil, which is also false because first is already nil. And then first dot next is also not equal to nil, which is also false because first dot next is also already nil. So we end up in here. So we got the two values. So that will be, let's check the slow and fast value. So slow, slow value will be 2 since we end up here, and fast value will be nil. Right, so what I want to do in here is I'm going to reverse the second half of the linked list. To do that, we may use like something called previous, is a better name, and we will name as a links node because this is the data structure given here. And it's also mentioned that we are using the singly linked list, not doubly linked list. So if it is a links node, so what we are going to do is we will put our current at the slow. So what I mean by slow is we are initially at here, and which is also current. And I'm gonna iteration through like current is not equal to nil. What I mean by I'm checking this is nil, no. So I'm gonna iterate through the next. Let's go next will be current of next. We are putting the next in here. Let's do something called test. Let's call that as next. And I'm gonna put the next as a previous since our original previous is nil. So I'm gonna put the list node is nil in here. So this is for the next, and what I want to do is I'm gonna put the previous is current. I just put the previous is a current is which is currently at the slow, so which became 2. And at the same time it became the nested loop because if I appointed that the 2 is here, so I will have a next. So it's began like this just for the sake of visualization. And then I will still check if the current is still not equal to nil or not. So I will run through until it happen. So technically we just redirect the linked list to reverse cell. And then if we really check the value of previous in here, so the previous will return the end up in 1. So we will walk until the previous end up in here. So if everything went well, I think we can do our evaluation. Let's go like first and second because I don't know how to name it. So first will be the head and second will be the previous. And we will have another variable called result to return it. And to do that, what I want to do is I will check the second is not equal to nil. I'm going to run through the result will be the mass of result and that will be combination of first dot value and second of value option at 0. Let's do the try run. Not sure what happened. Okay, I got the time limit easy. Okay, I missed the one thing here because I need to link back the current as a next. If not, that will be a real struggle. Alright, let's try to run again. Oh wait, what did I do wrong here? Let's check together. First donate is nil. Previous and current. We check the current together. The next. Oops. I think I need to look through to here. Sorry about that. I was too rushed. First of names and second will be second dot x. Cool. Alright, so if we want to submit the problem, I think the time complexity will be the O of n. Let's check together. The space complexity will be the O of 1 since we don't use any spare memory in here. Alright, so as we expected, it's doing well and hope you guys enjoyed the video and I'll see you in the next one. Bye!